一刷根39大林邦呀，腾邦腾腾啊巴扎呀扎呀。
Ecosystems, kelp forests, for over 2 decades. I'm introducing Brian because he came to Santa Barbara in 2008 and really made an impression on our community, so much that we are probably going to get an experimental floating kelp forest in our channel off the Santa Barbara coast. It's kind of working its way through. And we brought him we have a series called Civics 101 for Climate Change. It's a series that we bring speakers to focus around climate. And our thing that talks about the 4 doables of change that we see as an organization, Santa Barbara Permaculture. Brian has developed this strategy, which he calls Marine Permaculture, for restoring kelp forests. Dr. Brian von Herzen has a degree in physics, engineering, and planetary science, because he's a really smart guy, which I couldn't get one. He's the executive director of the Climate Foundation, which is located in Woods Hole. That's a big think tank area, I can tell you that. Its projects take place in the Philippines, Australia, and a potential one in Santa Barbara. Let's all welcome Brian von Herzen to IPC 15, Taiwan, in his first IPC presentation. Thank you.
Thank you, Wes. It's so great to see you, and greetings from the hinterlands of the Sunshine Coast of Queensland, Australia, unceded Jeannie-Barra territory, not far from the home of Morag Gamble and the Woodford Folk Festival. I'm so happy to be joining you. It's been 3 years since IPC 14 that we enjoyed here in Brisbane, Australia. And so much has happened in the last 3 years. Dave and I have published a wonderful journal article on marine permaculture, applying Dave's dozen design principles to the marine environment, along with Scott Spilius, PhD, who's now in Tasmania. So I'm very happy to join you here. I'm looking forward to describing for you a lot of the advances that we've made, not only with marine permaculture, but in the second half of my talk, I'll get into some of the most recent developments with freshwater permaculture as well, which I think may be applicable to so many of you that may be further inland, and the important developments that we can look at how our aquatic environments can work in harmony with our terrestrial environments to really regenerate incredible ecological value chains, I'll say. And then finally, there are some very interesting developments in Taiwan that I'd like to share with you at the end, just regarding some of the key freshwater permaculture innovations that are happening there, and some research that we're doing towards marine permaculture in Taiwan as well. So with that, I'll share my slides and look forward to discussing this with you. Let me know if you have any trouble seeing these slides, but assuming that you're seeing them well, I'll proceed accordingly. At the Climate Foundation, we've been working on identifying nutrient value chain gaps in seas and soils. It started with a lot of work we did with biochar in the past decade, and it's really progressed exponentially since then. Since our last meeting, we were very honored to receive an X Prize for carbon removal, but we may have come for the carbon originally, but our work to really develop aquatic and marine permaculture, it's so much more about regenerating ecosystems and ensuring sustainability. We like to say, well, the climate disruptions that we face are a major threat to food security for humanity and to millions of other species. And regenerating these ecosystems at the same time we're building sustainable value chains is really a key priority. In addition, we'd like to be able to measure the carbon balance that occurs as a result of regenerating these ecosystems. And more recently, we've even found the opportunity for climate repair to keep our local coastlines and regions cool and survivable during difficult decades to come, and building in climate resilience to everything that we do. The challenge is this: more than 90% of global warming goes into the oceans today. And so many of the marine ecosystems are on the front lines of climate disruption. We've seen losses of 95% off of Eastern Australia, losses of 90% off the coast of California, and losses of 60% in ASEAN nations, including Indonesia and the Philippines, during the marine heat waves where the water becomes too warm and the nutrient levels too low. And so we've really tried to design around those challenges with an approach with the principles of marine permaculture. I'll provide some examples of how marine permaculture has helped. And this picture on the left here represents a quarter acre of marine permaculture viewed from above from a drone. We have multiple platforms that lift and lower this platform each day. And the seaweed goes down deep at night and comes up during the morning, and that provides nutrients and as well as sunlight in the top meter of the sea. We've seen squid eggs, we've seen sea turtles, and we've seen game fish on our platform. In fact, when this photo was taken, there's a not so small 1 or 2 foot Pacific green sea turtle just off the side of the platform, enjoying the habitat that we've created. So we were very happy to see this kind of natural validation. One thing that we've learned over the last 2 or 3 years is that while we could upwell water to provide the deep nutrients and really address that gap that's occurred due to ocean warming, it's far more cost effective and energy efficient to actually lower our seaweed platform at night below the thermocline, below the nutricline, to where there are nutrients in the water depths of greater than 100 meters deep. So the seaweed spends all night down here in the lower zone. And then at sunrise, we lift the platform up with marine solar energy, and the seaweed absorbs sunlight and carbon dioxide in the top meter of the sea. And the net result is really astounding. We've seen growth rates exceeding 100 to 300% per month in the green lines for the deep cycled seaweed, whereas the surface seaweed didn't grow much at all because of the lowered nutrient levels in the surface waters. And we've seen this from 2020 through 2021, 2022, and even 2023. So we're very happy to have these positive results. We're now entering phase 4, and we have just deployed a few weeks ago 2,500 square meters. That's over half an acre. It's a quarter of a hectare. And we're one step away from doing an economically sustainable hectare of marine permaculture in the Philippines, which is our flagship location. And we hope to bring this to other ASEAN nations. In fact, there's some new collaborations with Taiwan that we'd love to tell you about. We're working with National Taiwan University and 3 other universities to demonstrate the carbon cycling and the effectiveness of marine permaculture, not only with the deep cycling technique, but we actually survived a Category 5 typhoon, Super Typhoon Rai, in December 2021. We lowered our platform just 5 meters below the surface, and it survived 5-meter waves and 120 knot winds. And not only was the platform intact after the hurricane, but most of the seaweed was still on the platform, and we were growing seaweed the next day and provided seaweed to our neighboring communities within a few months later so they could rebuild their farms that were destroyed during the hurricane. So we're very grateful to have this technique that is in fact highly hurricane resilient. And that's so important for Taiwan and other ASEAN nations seeing more and more severe hurricanes each year. One key aspect of this is that these seaweeds normally grow near the shoreline, but of course, each ASEAN nation has the exclusive economic zone out 300 kilometers from their shorelines. And this represents a vast area that rivals or even exceeds the agricultural land that's available. And so it's a degree of freedom that we have to regenerate life in the sea, especially because the warmer oceans means that we've seen less productivity, less primary productivity, photosynthesis in the oceans in recent decades. And this is a critical approach that lets us to regenerate the primary production in the sea and get back to the primary production that existed pre-industrially. finally, I should mention that about a quarter of all the seaweed falls off the platform during growth and sinks 1,000 meters a day to the deep seafloor, where it remains for centuries. It's like watching leaves falling from the trees. If we can count the leaves and we know the carbon that's going in those leaves, then we can actually estimate the carbon removals as we grow seaweed for food, feed, and fertilizer opportunities. Those, in fact, are the first 3 of a dozen value chains that we've identified for marine permaculture seaweed. And I think there are similar value chains on the freshwater side as well, which I'll share with you later today. So I'm very excited to do that. In fact, our first product, our Climate Foundation, is a nonprofit startup studio, but we're spinning out sustainable regenerative businesses starting in the Philippines that can actually help to regenerate horticulture and permaculture and agriculture on land. And that is the seaweed foliar biostimulants are amazingly effective at that. With 20% less fertilizer, it's possible to get 15 to 30% higher yields. You can see at the lower left here, the control region is a normal color and a normal height, but the very same test region right next door produces a greener crop with higher yields and higher, in this case, taller rice. And so we've seen dramatic effects in rice. In fact, if you look at some of the fertilizer-specific yield, this is measured literally by the number of rice sacks per hectare divided by the number of fertilizer sacks per hectare. And the blue lines are the tests that we've done with our biostimulant formulation from seaweeds. And the red lines are the control. And you can see a dramatic increase in the yield per sack of fertilizer used. Now, this would apply equally well to organic techniques. And so if you have a limited amount of organic fertilizer, really, we think of the biostimulant as a fertilizer multiplier. And so we've actually we've shipped a case of the Big Roe biostimulant to Taiwan for this conference. I believe it's going to arrive on Monday. And I hope for those of you who are at the conference and are able to join December 4th through December 8th, we'd like to be able to provide the biostimulant to you. In fact, I'd like to get organized with Wesley a sign-up list, and we'll do a raffle for some of these biostimulant leaders. So I hope we can do that tomorrow, and happy to tell you more about this regenerative approach that we're hoping we can enable and really get much broader adoption in permaculture around the world. So we're very happy to see these improvements and the fertilizer-specific yields, and it results higher yields with lower fertilizer costs. In addition, we've had actually more than 200 rice farmers now engaged with the biostimulant applications, and that's resulted in dozens and dozens of trials. Very happy to see the increased yields, and it's not limited to rice. We find that most flowering plants are benefiting from this approach. So we're looking forward to really engaging with the permaculture community to see how these organic biostimulants can actually help to utilize more effectively the organic nutrients that are available with organic farming practices. Now, we have this value chain that includes biostimulants. We're regenerating the primary production in the sea. We have a biorefinery that produces multiple products, including dry pulp and carrageenan for food products. The dry pulp is very effective as feed and food products and food ingredients, such as texturizers and moisturizers. So we're very encouraged by that. And then finally, we do want to measure the carbon removals that occur from the seaweed that naturally falls from the platform into the deep ocean. Our platforms presently are in 200 meters of water, so they can be very deep. In fact, we have some of the deepest moored seaweed platforms on the planet. I should also mention that every square kilometer of marine permaculture can potentially not only see approximately 8,000 tons of CO2 removal from the leaves falling from the tree, but also we can avoid using that 20% fertilizer reduction means 12,000 tons less CO2 from fertilizer manufacturing, avoided emissions. And then finally, because there's 20% less nitrate fertilizer going onto the soil, that can avoid 10,000 tons of CO2 emissions of nitrous oxide, which is produced from the nitrate fertilizers. To that end, we are working with National Taiwan University and 3 other universities, Princeton, Scripps, and Rutgers, and have finished our first year of our 2-year carbon cycling study, which is designed to actually measure the carbon cycling underneath the platform depicted behind me right now on the video in my background of the marine permaculture platforms. And we'll be using a combination of gliders, underwater gliders and sediment traps and water samples to really do the scientific study. We hope to have the publication results within 18 months from now. And we are hoping that this will lead towards really a way of measuring the ecosystem services that marine permaculture can provide. As I mentioned, Dave and I have published with Scott Spilius Marine Permaculture Design Principles for Productive Seascapes. The deep nutrient availability is just one of many permaculture design approaches that are essential. And what I love is that Dave designed these permaculture design principles, perhaps initially for a terrestrial environment, and yet they fit remarkably well to the marine ecosystems and work incredibly well. In fact, I wonder if we might not be able to use the permaculture design principles to develop a sort of social permaculture that could really guide our governance and our ability to make decisions in a decentralized way in the future. So I'm very hopeful for expanding on the permaculture design principles as we go forward. So I'm going to segue now from this marine permaculture world, and we're so happy to have the successes and be right at the cusp of building economical sustainability. And as Wesley mentioned, we've raised about half the funds that'll be needed to build a first permaculture pilot in the Americas. And we're also working with stakeholders across Australia to develop a first pilot marine permaculture in Australian waters as well. With that, though, I'm going to segue to freshwater permaculture, and that is specifically, how could we apply some of these principles to more freshwater environments? I have as one example, Lake Gula, which is just a few kilometers away from me and from where I gamble. This has been the largest swimming lake in the Southern Hemisphere, from what I understand. It is a living biofilter. It is really quite a wonderful example, just kind of an illustrative example. But I'm actually going to spend most of the time describing how we might use regenerative plants like Azolla, actually, with collaborating with the Azolla Foundation, who's done a number of research. They were kind enough to lend me some of their slides. I'd like to share with you, because for those permaculturists who are more inland, it could be that freshwater permaculture is even more applicable than marine permaculture. So Azolla is an aquatic fern that has a 50 million year history. It's a remarkable superorganism, which is actually a symbiosis between this aquatic fern and a marine cyanobacterium, Anabena, that is able to fix nitrogen, and it lives in the tissues of the Azolla plant. And it ends up being a remarkably fast-growing plant, which makes it very similar, actually, to some of the algae growing behind me, which can grow up to 100% per day, which is really remarkable. And we're very fortunate to have discovered this. In addition, no soil is needed for it to grow. It can grow in freshwater and even slightly brackish systems, and it doesn't threaten other crops. And it can potentially be a really valuable approach to addressing some of the climate challenges that we're facing. These include eutrophication of many freshwater environments, and that results in cyanobacterial blooms, nitrate and phosphate runoff, and chemical fertilizers. Azolla does a great job of soaking up these fertilizers, and that phytoremediation can be a very key aspect of what we're doing. These slides are from the Azolla Foundation, and they've identified a number of benefits. I would like to focus on 2 of these, and that is biofertilizer for plants and soil remediation here on the left, and on the right, feed for ruminant and non-ruminant livestock and aquaponics. So I see a huge opportunity for us to lean into and research together. We see some Azolla blooms from time to time here in Australia even, And it really, Azolla is actually trying to help because it absorbs excess nitrogen and phosphate compounds from waterways and enables this to go better. The Azolla biofertilizer has actually seen a remarkable history in ASEAN nations. It's been used for thousands of years in the Far East to provide biofertilizer for rice paddies. And in fact, I just met earlier today a wonderful gentleman from Vietnam, Minh Pham Gia, and his grandfather wrote almost 100 years ago an Azolla description in Vietnam by Nguyen Cong Tu. And this was a 1930 Azolla publication describing the benefits. It's a natural green fertilizer. There are many festivals now in Vietnam and I think one of the reasons that Vietnam is able to exceed 7 tons of rice per hectare is the fact that they use Azolla quite a bit. That is almost twice as much as the average yield per hectare that we have currently in the Philippines. In addition, it's been utilized in India and has potentially, in some cases, doubled the yield of rice in India. And in China, it's been used for thousands of years. But with the advent of chemical fertilizers, so many people and so many farmers have forgotten this natural, really freshwater permaculture approach using Azolla and rice. There are many benefits. It's the nutrients from the Azolla are easily assimilated. It fixes nitrogen, as I mentioned, and it has many, of course, beneficial organic compounds and builds healthy soils. In addition, it's got an unlimited supply of nitrogen from the atmosphere, and it can be grown at very low cost where it's needed. Now, there are some anecdotal examples. For example, bananas in Ecuador with Azolla fertilization and without. And this has really had a dramatic effect with the rightmost plant being including Azolla. And then there are manual methods that the Azolla can be harvested. And there are also some more automatic methods that have been pioneered in California and elsewhere for getting the Azolla from the freshwater bodies and utilizing it locally. In addition, it's very popular with livestock. I've seen chickens fighting over Azolla, and it's really quite nutritious. And I've got several friends that put it on their salads, and it's quite eco-friendly. So with that, I do want to describe another example in Africa. This is thanks to the Azolla Foundation, which was set up more than a decade ago, a dozen years ago. And there's an incredible permaculture with Azolla and rice and ducks and fish that has really quite a transformative effect. I was so happy to see this. Now, there was in 2018, so many orphans in Sierra Leone and elsewhere associated with Ebola. They were, well, thousands of parents were killed and more than 20,000 children orphaned, and they were forced to live in slums and scavenge for food from rubbish areas. And so 4HEO was founded in 2014 and began to rescue orphans in 2015. With the Azolla Foundation's help, they began to use Azolla as a biofertilizer for rice. And the results were amazing with doubled rice yields in Africa and surrounding areas. Provided income for schools and facilities for Ebola orphans. And they added ducks and fish to the paddies and developed a sustainable ecosystem, such as that of Takao Verona in Japan. And that's described in the Azolla story. The Azolla story is a book that I have just begun reading myself, and I believe it's extraordinary because there's so many lessons to be learned there about how to integrate permaculture design principles into freshwater environments. In fact, it was published in English and Spanish in April 2024 and translated into Vietnamese in 2022 by Dr. Minh Pham Gia. In fact, it was even taken into space by a Vietnamese astronaut, Pham Tuan, took Azolla into space for scientific research. I believe they had a week in space, and then they tested growing the Azolla when it returned to gravity and had very successful results. So very happy to see that connection. I especially am inspired by the ducks and the fish, which feed on the Azolla to produce organic meat and eggs. By the way, the eggs from the chickens or other livestock have DHA and EPA in them because those omega-3 fatty acids are produced in Azolla. It's actually produced by the Anabaena microorganism, and it's one of the very few freshwater plants that contain EPA and DHA thanks to this marine organism living inside the freshwater Azolla. So it's a key issue for 500 million vegetarians in India who do not have access to much in the way of EPA and DHA. And I would add that the United States and Australia also have very low levels of EPA and DHA in the diet. And so this is really profound. It's also considered a mosquito fern in that when it covers the surface, it actually reduces the populations of mosquitoes by orders of magnitude from time to time. Finally, Takao teaches his method of farming in Japan, and the practice is spreading, China and South Korea being a couple of examples. There are claims that Azolla can reduce emissions of methane from rice paddies by up to 60%, which is very intriguing to me because it's such a key greenhouse gas in terms of today's climate situation. And finally, I want to mention that for these critical communities, the orphans that suffered so much in the past now are enjoying much improved lifestyles because of this improved outcomes, and it's described in detail in the Azolla story. Finally, I do want to mention that the feed for livestock and aquaponics is profound. The livestock love to eat Azolla. I've got a number of friends that put Azolla on their salads as well, and it's really quite an incredible feed supplement, I would say, with higher yields and, of course, incredibly high productivity. And the result is that there are many nutritional benefits. It lowers the cost of feed for the animals. They get higher yields with lower costs, and thus, I think it has a profound effect. And milk yield has been demonstrated to be highly improved in India, for example. And finally, there's some great examples where it's used with goats and sheep and many livestock. And so we've seen a wide variety of improved outcomes, cows producing better milk. And in fact, it's also being used with pigs. And so I think whether it's used for food, feed, or fertilizer, there's a huge potential and, in fact, improved health outcomes for these creatures who eat Azolla as well. And so it has really profound results. And we're very happy to see that the combination of Azolla plants, primary grains like rice, and fowl and fish has a great outcome as a result. It's been used with tilapia. And in fact, I think in my hometown of Woods Hole, New Alchemy actually worked with Azolla and tilapia as far back as the 1970s. And so it has some really profound effects. I think many of our farmers have forgotten the benefits of Azolla for rice, and it's really a profound outcome. Now, I just learned today that Taiwan has an Azolla seed bank, and this is at the Dr. Cecilia Koo Botanic Conservation Center, and they have there more than 450 varieties of Azolla in Taiwan, and these are in culture, and we still need to sequence them, I think, and to understand all their benefits. But this is just an example of how from sea to shining sea in freshwater and in marine environments, the permaculture design principles are alive and well. We're so grateful for so many organizations who have supported us around the world. And with that, I want to thank you and really open the floor to questions if we have time, and look forward to discussing with you how we can apply permaculture design principles to not only to our terrestrial environments, but to our marine and aquatic environments, and hopefully even learn some social lessons on how we can better organize ourselves by mimicking natural ecosystems. Thank you so much.
On Brian.
I can hear you now. Thank you, Wesley.
Okay. Okay.
I got the okay.
If Mike. Okay. We have
I would like to offer that maybe someone could type in the questions and I could read them back and provide them if you wish to put in the chat.
And so my hello.
I can hear you. Please proceed.
Okay, cool. Yeah, thanks very much, Brian. I really appreciate your presentation. It's very encouraging for the future of what's possible on this planet. Has me very excited. I've seen some of your studies, and in one of your marine permaculture rigs, I guess I'll call it, which you're growing seaweed off, it was using giant kelp. I've been doing a bit of research into different types of seaweeds and where they grow. I was curious about the context of what can grow and where, and I just wondered if you've been building a database based on where different kelp seaweeds grow and different techniques for growing them based on the type of seaweeds that you're growing.
Oh, thank you for that great question. We've been growing really quite a variety of local red, green, and brown seaweeds. And of course, the kelps are a variety of brown seaweed that grows in cooler waters. The waters behind me are actually in the Philippines, and we started with growing the red seaweeds, euchumatoid seaweeds, including Capophycus and Spinosum, which are native to the Philippines. Now, an interesting thing happened on the way to the marine permaculture, and that is, part of the permaculture design principles are to observe what nature's doing and to respond to it. And I'm very happy to say that, it turns out most of the seaweed growing behind me is actually a green seaweed that has been studied in Japan. The ulva genus of species is actually the fastest growing marine plant on the planet. with yields exceeding 100% per day with replete nutrients in seawater, and in the laboratory, they've even gotten up to 300% per day. So it's really a profound yield increase. What's interesting is ulva is in many ways a superorganism in the marine environment, somewhat similar to azolla in the freshwater environment. It's a great opportunity because this azolla has a high protein content. Well, azolla has about, I think it's over 20% protein. The ulva genus of species of seaweed is at least on the order of 10 to 12% protein, and it grows remarkably quickly. And in fact, more than half the seaweed growing behind me here is ulva seaweed. And so this ends up being, ulva species exist all over the planet, and it represents an opportunity for us to really consider how we might use this as a green manure, as a fertilizer, as a biostimulant, as a feed supplement. The fish seem to prefer ulva over other species. So one of the benefits of growing ulva on our platform is that the fish eat the green seaweeds and we harvest the red seaweeds, but we harvest some of both. And so this is just one example. With 14,000 species of red, green, and brown seaweeds, there's a great opportunity to cultivate local varieties. And we're designing this marine permaculture platform to provide a substrate for most species of seaweeds that have holdfasts and they secure themselves. So I think it's really a set of techniques. And we're trying to apply the permaculture design principles and noticing what nature is doing. We've found around us thousands of sardines, hundreds of tuna, dozens of dolphins, and even a couple of whale sharks have taken up residence over the past 3 years on our platform. So nature has voted with her fins. She said that, we've got the good stuff, the productivity, and we're very encouraged by this natural validation that we're on the right track. And by observing nature and seeing what nature is doing, we can perhaps utilize the many different trophic levels that exist on the platform and the many ecosystem services that these aquatic regenerative environments can provide. So thank you so much for that question. Looking forward to others.
Since 还有人有问题吗？
I'm not sure I heard a question.
Hi, thanks for your presentation. I'm curious about the azolla. Like there's a positive effect of the mosquito larvae not growing, but just wondering about any negative effects about the blocking of the light.
Well, that's a great question. Azolla, I think, it's a wonderful tool, and we have to understand where to use it and when. The challenge is that, azolla can grow, if it's got tons and tons of nutrients, it's going to keep growing. And unless it's harvested each week, you can get 4 times the original biomass in 1 week. And so it needs to be harvested weekly in order to, have a healthy environment, because if it accumulates too much, it can actually overaccumulate. It could, if it's not harvested, it could actually sink and go anoxic. And so it's important to have a healthy harvest, perhaps weekly, that could go to chickens, it could go to livestock, it could go to other applications. And you can get omega-3 eggs and omega-3 milk by feeding it to livestock. And so I think it's just important to understand the speeds and the feeds and to work with it in a way so that it remains oxic, it can be regularly harvested. And these are the kind of constraints, but it's a way of addressing a nutrient excess. In particular, azolla grows with duckweed. The duckweed does a great job of drawing down the nitrogen. The azolla can draw down the phosphorus even in the absence of nitrogen. And so the two of those together can be a remarkable freshwater feed supplement, if you will. So I think we just need to understand the constraints and understand what approaches work and really be clear about the need for regular harvesting, for example, to ensure that the environment and the ecosystem remains healthy. Thank you.
One more question. Okay.
Thank you so much. I want to know the difference between algae and azolla, because now I get a little bit confused. In a pond, they have found a lots of algae. Can we use that in the form of azolla in a soil? Now, after your presentation, I'm totally confused now.
Yes, no, thank you for that question. That is a great question. The azolla is remarkably different than the freshwater algae. It's fairly challenging to harvest the freshwater algae because it's a microorganism. The azolla is a macroscopic freshwater fern, and it has inside of it a cyanobacterium that is the Anabaena bacterium, and that actually provides the nitrogen, and it provides the some of the key photosynthetic aspects. And so really azolla is a macroscopic multicellular plant that is contrasted from the freshwater algae that can cause problems. The nice thing about the azolla is it can safely absorb excess nutrients in waterways and draw down the nutrient levels to safe levels. So it's very good at phytoremediation. So that's a contrast to in the oceans, we have microalgae, plankton, which are a bit like a blue-green algae. And then we have macroalgae seaweed that is the macroalgae. So I would think of azolla as being analogous to the macroalgae seaweed. And I would think of the micro algae in the freshwater environment like the microalgae in the oceans. So think of the azolla as the analogy to the healthy seaweeds that grow in our oceans. And of course, we can hold on to the azolla because it's a macroscopic plant. And thus, it offers many benefits of being fast growing, while at the same time being manageable and harvestable. So think of the azolla as your freshwater seaweed plant that can be very effective and managed effectively in aquatic environments, including rice.
Okay, thank you, Brian. Much appreciated. We'll see
Thank you.
up
It's
in
great
Santa
to be.
Barbara again.
Yes,
Take
look
care.
forward to that. Thanks so much. Take care.
一刷根39大